Let's sum up the characteristics of well-behaved indifference curves. The indifference curve should be downward sloping, representing the trade-off between consuming one good and another good. In other words, if I need utility to remain constant as I consume more of the x-axis good, I necessarily need to consume less of the y-axis good. The indifference curve will also be convex. That means that the curve is getting flatter, or the slope is decreasing as you increase consumption. And that's related to our diminishing marginal utility, because as I consume more and more and more, say food on my x-axis, each unit of food is worth a little less. And so the decrease in my y-axis variable gets smaller and smaller and smaller to offset the smaller increase in marginal utility from my x-axis good. And the indifference curve should be differentiable, right? We've seen these nice curves. We are going to look at some indifference curves that are not differentiable. We'll see what happens when we get there. All right, so the last thing that we want to do to describe our utility function is to calculate what's called the marginal rate of substitution. The marginal rate of substitution helps us define a little more concretely that trade-off between the x-axis good and the y-axis good, right? Our two consumption goods. So the marginal rate of substitution is the slope of the indifference curve. And we've just talked a little bit about how the slope of the indifference curve is decreasing as we consume more of a product, representing that changing trade-off between my two consumption goods. But we can calculate the slope of the indifference curve by calculating our marginal rate of substitution as the marginal utility of one product divided by the marginal utility of the other. And to do that, remember, marginal utility is the derivative of the utility function with respect to, say, x divided by the derivative of the utility function with respect to y. That's how you're going to calculate your marginal utilities, and then we'll put them together to get our marginal rate of substitution. Let's do an example here. We're going to use the same simple utility function, food times clothing, but we're going to use a different indifference curve. So now I want to derive the equation for the indifference curve passing through the point 10, 20. So first thing I have to do in this example is figure out how much utility I get from this point. So I plug my quantities into my utility function, and I can see that at that point, my utility is 200. So I want to find the indifference curve for a utility of 200. All the different combinations of food and clothing that would give me a utility of 200. So this is my equation for my indifference curve. I'm going to plot some points here to help us think about what it looks like. Again, utility at each point along the indifference curve will be equal to 200. So I'm going to put 6 of them here, 6 points. And then I just want to think of some numbers that multiply to be 200. So I've got 4 and 50, 5 and 40, 10 and 20, right? And then the inverse is here, 20 and 10, 40 and 5, and 50 and 4. All right, and I can plot some of those here on the graph to get a sense of what my indifference curve looks like. There. Okay. So same shape as before, right? Same utility function, but this is a slightly different curve than in the previous example. You'll remember we had a point at 10, 10, 25, right? in our previous example, our indifference curve would have been down here. So here we are, same utility function, higher indifference curve, meaning that we have more utility here. We have 200, right, instead of 100 like we had in the previous example. So notice that, right, we have this shape where the slope is getting flatter, so that tells me something that my marginal rate of substitution is going to be decreasing, right, with consumption. So as I consume more F, my marginal rate of substitution, the slope of my indifference curve will be going down, getting smaller. Okay. So let's go ahead and derive our marginal rate of substitution for this indifference curve, for this utility function. So I've got marginal rate of substitution, and now there's usually an order here to, which one goes on top. It's a ratio of the marginal utilities, but you have to know which is in the numerator and which is in the denominator. So here you usually will see, you can write FC. That means first we'll do F, then we'll do C. So we want marginal utility of F over marginal utility of C. So marginal utility of F, that's just the derivative of the utility function with respect to F. And because we have such a simple function, that's pretty easy. That's just C. Marginal utility of C is equal to the derivative of the utility function with respect to C, which again is pretty easy. It's F. Now don't get confused here, right? Because like the marginal utility of F is C and the marginal utility of C is F. But if you just write it out, it won't be so confusing. Okay. So at the end of the day, then my marginal rate of substitution is given by C over F. And so I can calculate that to show you here for these points what the marginal rate of substitution looks like. Right? So I've got 50 divided by 4, that's 12.5. I've got 8, 2, 1/2, 1/8, and then this is 0.08. Again, what you already knew is that the marginal rate of substitution is the slope of the indifference curve. Slope of the indifference curve is getting flatter as we consume more. And the reason is because as I get out consuming more and more and more food, each unit of food is worth less to me in terms of marginal utility. And so the trade-off between the marginal utility of food and the marginal utility of clothing is changing as I consume more and more food. So this can be summed up here with this law of the diminishing marginal rate of substitution. This is only, again, applicable for our well-behaved utility functions, but you want to first understand this well-behaved case, and then we'll look at some variants of that moving forward. When we have these nice convex indifference curves, it also means that our marginal rate of substitution will be decreasing.